Hello. Now we are going to look at graphs of proportional relationships. And what we will always be talking about pretty much is linear relationships, so straight line relationships or proportions. Direct proportion is a special case of proportion where we have, if we graphed it, a straight line going through the origin. What this means is that if we double one value, we would double the other. So if x got 3 times bigger, then y would get 3 times bigger. So there's a direct ratio between x and y. Things can still be proportional, however, even if that's not the case. We could still get a straight line relationship between y, the output, and x, the input. And we would say that they are proportional or linearly proportional, straight line proportional. And that would give us the equation of a straight line for their relationship, but it wouldn't go through the origin. And if we doubled x, we wouldn't double y. So direct proportion means their effective x and y, the input and the output, are in a ratio. If x gets 3 times bigger, y gets 3 times bigger. But we can also have the more general proportion where as x increases, y increases, but we don't have them both doubling at the same time. So if we look at an example here, we have the relationship between miles and kilometers. So miles going along the x-axis, kilometers going along the y-axis. And we have the relationship graphed in green for up to the first 50 miles or 80 kilometers. So what we need to be able to do is recognize what type of relationship we've got, and then we need to be able to use our graph to read some information off. So our first job is, what type of relationship have I got? Well, I start off going through the origin. I go through 0, 0. And if I look at some points where my line crosses the grid lines nicely, I can see that that happens at 25 miles and 40 kilometers. So that point there, 25 miles and 40 kilometers, is roughly on the green line, and 50 miles and 80 kilometers was roughly on the green line. So 25 miles gives me 40 kilometers, and 50 miles gives me 80 kilometers. When I doubled my miles, I doubled my kilometers. Well, where is that true? That's true for direct proportion. So I can see that this green line is a straight line that goes through the origin, and I can see that if I double one of my variables, miles, I double my output variable, kilometers. So I can see that miles is to kilometers is directly proportional. Now that I've established that, let's have a look at some of the questions for reading off of the graph. I have what is 30 miles in kilometers. So I go to my miles, which is in the door, and then I go up and across as neatly as I can. And I end up, I need to be careful when I'm given these questions of exactly how I'm counting in these boxes. So these boxes are going up in fives. So this is 45, this is 50. So I am at approximately 48 or 49. So I would read that as being 48 kilometers. What's 50 kilometers in miles? Now we're starting with kilometers and we're going to miles. This is going to be quite close. And I go across my kilometers and drop down, and I'm at about 31, 32 miles. So I'll call it 32 miles. And you see we have to be fairly accurate. You would be able to use a ruler going across here, but make sure in the exam, if you're asked to read something off of a graph, you put in these dashed lines. They're your workings. They're showing the examiner, I used the graph to get the answer when I was asked to use the graph to get the answer. These are not kind of minor points. If we don't have that there, there's a danger we might not get the marks. So if we're asked to use the graph, make sure that we use a pencil to draw in that we have used the graph using our dashed lines to show how we are reading from 50 kilometers over to our line and down. And effectively each time here, what we are doing is getting the coordinates. It may not always be the most obvious thing, but if we are at 32 miles, gives me 50 kilometers. So continuing, we want 20 kilometers in miles. So we do exactly the same thing again. We want 20 kilometers. So we start at kilometers. We want the coordinates essentially. So we go across and we go down. And we are at approximately 12 miles. Oops. And finally, 25 miles in kilometers. So 25 miles, we've actually already done this one. We go up miles, and we're effectively getting the coordinates. So when x is 25, y is 40. Now, what is the approximate equation of the line? So the equation of the line, I know based on my understanding of this relationship that the equation should be in the form y equals mx, because in general the equation of a line would be y equals mx plus c, and in this case c is 0. I'm going through the origin, so I cross the y-axis at 0, so the constant is 0, so I know the equation of my line should end up looking like this. So I have two options. I can go with this understanding and figure out what the slope would be, or I could use the equation of the line formula, and we'll write out both. So if I know that I have this relationship here, what falls to me is to figure out m. And as I'm dealing with a graph, I may do this visually. It's worth noting this is an approximation because this is not the exact relationship between miles and kilometers, but it's a useful rule of thumb. So to find the slope of the line using rise over run, I go to where the green line nicely crosses my grid lines, or the best places that I can find that it crosses my grid lines. And I can see here that it crosses at the miles is 25, kilometers is 40. So 25 miles gives me 40 kilometers, and at 50 miles gives me 80 kilometers. So reading across like that. So if I run across by that amount, I rise by that amount. And I don't have any really nice crossings, any really good crossings between those two, so those are the two I'm going to go with. So I'm running across from 25 to 50, so I've run across by 25, and I have risen by 40. So my rise over my run is going to be 40. Is going to be 40 all over 25. And I can simplify that by taking my common factor of 5 out to get 8 over 5. So my kilometers is to miles. Kilometers equals, so this is y equals mx. Kilometers is to miles is 8/5 of a mile. Capital M for miles. So that is the equation of that line. If I have a particular number of miles, I multiply that by 8 over 5, and that will give me either the number of kilometers. Now I can also write this out using the line formula from our log tables, and I'll do that now. And working down through those equations, we end up getting the same answer. So both methods are valid and both methods are useful in different circumstances. Now if we have a look at mobile phone deals, so we have the cost given in the y-axis and we have the hours of calls that we get with our deal written on the x-axis. And immediately we need to be careful. The y-axis is counting in 5s and the call in hours is counting in 1s. So this is something we need to watch out for in these questions. The x and the y-axis don't have to be counting up by the same amount, and we need to keep that in mind as we work. Our first job is to figure out which one of these offers is which line. So we have offer A is €5 per hour for calls. Offer B is a €10 starting charge or flat charge plus €2.50 per hour for calls. And option C is unlimited calls for €20. So option A, €5 per hour for calls, would be it would be going through the origin, and it's €5 per hour for calls. So that means that we are talking about a directly proportional relationship, because it goes through the origin and has a constant rate of change, a constant slope. That allows me to immediately say that the only one that's directly proportional is the red line. So that's going to be A. And then we have B, which starts at €10 and has a €2.50 per hour charge. So that means 250 is 5 all over 2. If we run across by 2, we rise by 5, and we're starting at 10. So that means that our green line must be option B. And then C, unlimited calls for €20. That means that no matter how many calls we make, the charge is still €20. Doesn't matter. So that means that the blue line must be C. Now, what is the cost of 5 hours on offer A? So 5 hours of calls on offer A is the red line. So we go up from 5 hours up to the line A, go across, and that's €25. How many hours for €15 with offer B? So how many hours for €15 for offer B? So we go across the green line for B and down. That's 2 hours, or 2 hours of call. The cost of 3 hours on offer B. So we're going up to the green line from 3 hours, and this time we don't go up nicely. We have basically gone halfway up, so that would be about €17.50 or €18. And the cost of 6 hours on offer C. We go up to the blue line for C, and we know it doesn't really matter where we go to, because that's always going to be €20. Now, what would be the equation of the line A? Well, we know it's directly proportional, so we expect that it should be in the form y equals mx, that they're in a direct ratio to each other. And we know that the slope, if I run across by 1, I rise by 5. If I run across by 2, I rise by 10. So I can see my slope is 5 over 1. So cost is going to be 5 all over 1 times time. So time for calls, I've called T. Equation of B, well, this is still linearly proportional, so it's a straight line. So it's going to be y equals mx plus c. C is where I'm crossing the y-axis, the cost axis, which is 10. So my cost in this case, I'm going to have plus 10 on the end for where it's starting off. And the slope, if I run across by 2, I rise by 5. So rise over run. I run across by 2, I rise by 5 times the time. And finally, the equation of C. Well, the only thing I need to say is that the cost is €20. There's no effect of the time. The time doesn't come into it. The cost is just equal to €20. And that describes the relationship. And I don't need to refer to the time because the time doesn't change anything. So that is how we look at graphs of proportional relationships, and particularly linearly proportional relationships.